This is Mr. Coates, and this is APES lecture number 43, Reducing Air Pollution. We've talked a little bit about how to reduce air pollutants that we've seen earlier, but we want to get into specific technologies now that help us reduce air pollution rather than getting into laws, but getting into actual specific technology. So we're going to look at some of the major technology that allows power plants to clean up their act. This is what we call a Baghouse filter. And in a little bit we'll see how that works, but this filters all kinds of particulates from a large power plant. We can also switch the type of cars we start driving. We've seen a big push lately in electric cars and going more and more electric and get away from those fossil fuels. That will definitely help cut down on the amount of VOCs and NOx that are released via automobiles. And then also changing the way we power things. We've already made a huge change in the United States getting away from incandescent bulbs that were 90% inefficient or 95% inefficient. And we're now going towards compact fluorescents. However, compact fluorescents aren't the best ones either because they can release mercury. So now we're starting to make this jump to LEDs, and LEDs actually are the best light bulbs. They will last the longest and they don't put out a whole lot of heat, so you don't lose a whole lot of energy. Very efficient type of light. So one of the first things I want to talk about is a complex topic called emission trading policies. In the United States, they came up with this idea to help reduce sulfur dioxide from power plants and from other industry. The way this works, and the other thing this is called is cap and trade. It should be trade, not TRE. It should be cap and trade policy. Basically what happens is that the United States sets a total limit on the amount of, and we're going to use SO2 in this example, the total amount of SO2 that can be released nationwide in a particular year. And from then on, the amount gets less and less. And so this is called the cap. And so typically what they want to do is that they don't want any more SO2 being produced nationwide than what that cap is. To ensure that, what they do is that they give pollution credits to certain companies. So companies can purchase these credits, and these credits will allow them to release so much pollution into the atmosphere. And some of these companies will actually buy extra credits to do this, although they will not pollute using those credits. They will instead sell those credits as a profit to a company that needs more credits. Certain companies are only allowed to buy so many credits, and if you pollute over that, then you can get in trouble. However, you can purchase credits from another company that has extra credits. And this is called the trade part. Each company is got an allowance, and if you don't use your allowance, then you can trade or sell your credits to another company. And so some companies are getting pretty rich because of this. And then some companies are actually polluting the same amount, however, they're buying credits from somewhere else. So in effect, the pollution is supposed to be, on nationwide average, going down. So this has been really good for sulfur dioxide in the United States. This has decreased sulfur dioxide emissions by 40%. Now, in the United States, we're also talking about doing this for CO2. In fact, a couple of years ago, there was a huge debate in Congress and the Senate over a cap and trade program for CO2. Now, this has been in place for a few years now, but it's still too early to find out if the cap and trade program for CO2 in the United States is really going to work. One of the problems with this is that you can actually cheat. Some people will say that they will build a power plant that will produce 150 credits worth of pollution. They'll build this power plant knowing that they're only going to produce 100, so all of a sudden they have 50 credits that they knew they weren't going to need, and then they can sell those credits and make a profit. So they're kind of starting to cheat the system. Over time, we'll see if CO2 happens to decrease in this country. The problem is a lot of this CO2 is being emitted all by automobiles, and unfortunately automobiles are not underneath the cap and trade program. The only way we can control automobile exhaust is through CAFE standards, and unfortunately we mentioned earlier the SUVs and diesel trucks are not underneath those CAFE standards. Now I want to get to just how we control pollutants in power plants. Power plants were the biggest polluters, especially coal burning power plants here in the United States. And with the advent of the Clean Air Act in the 1970s, those power plants really had to start cleaning up their act. So they came up with several different filtration technologies that all power plants in the United States typically have now, all coal burning power plants anyway. Some of those pollution control measures include electrostatic precipitators, Baghouse filters, Cyclone separators, and another one that we'll look at is scrubbers. But these first three all remove particulates, and one of the ambient air quality standards that we saw before was on particulates. Now the scrubbers, they have another job. The scrubbers remove only SO2 and some mercury. The way scrubbers work is that they spray the flue gas with a lime water solution, and the lime water reacts with the sulfur dioxide, and it can be the byproduct can be collected and formed into wallboard, and we'll see that a little bit later. Another waste product that can be reused from power plants is the slag. The slag is the leftover burned remains or ashes of the coal when they're done, and one of the things that slag can be incorporated to is into cinder block, and a lot of that cinder is left over from coal burning power plants. The slag can also be used in roadways and concrete mixtures, and can also be used in sandblasting. So there are some positive uses for some of these waste materials. The first type of air cleaner that I want to talk about, or air filtration device that I want to talk about, is the electrostatic precipitator. Now this sounds very fancy, but it's pretty easy. It works on particles having a charge on them. So as you burn the coal, the flue gas comes into the electrostatic precipitator from this direction. And inside the electrostatic precipitator are these plates, and these plates have a charge applied to them. They either have a positive charge or a negative charge applied to them. And they basically attract oppositely charged particles, just like a magnet does. And so after a while, these plates get covered in all these particles. And so what they'll do is that they'll stop the gas from going in this one, and they'll bang these plates and for all the particles to fall off of them. And so they use what they call wrappers, and these wrappers then will bang the plates, and all the dust particles and all soot and everything else will fall down into these hoppers, which then can be loaded into a truck. And then the truck will then either cart them off to some place where they can be reused in concrete, or they can be landfilled. But this is one quick way to get rid of a lot of particulates, is by using this method. And then once they're cleaned, then the particular precipitator can go back online. And so this gives us clean gas with not a whole lot of particulate left in it. Now another one is called a baghouse filter, or a bag. The dirty gas coming in this direction here, and it goes up through these filtration bags. And these bags, there's usually a huge building full of them. And these bags then have very small mesh size, and they collect all kinds of particulates. So as the flue gas goes in here, then the particulates start to clump, and they'll start to fall out of the bags into the hopper where they can be collected and discharged. Now after a while, the bags do get kind of clogged, so they shut this one down, and once again they have some kind of device up here that shakes the bags and really cleans them really well, vibrates them, so all the particulates then fall back down into the hopper and can be disposed of properly. So this is another way to really get rid of a lot of the particulate. The next one is called a cyclone separator. This one uses physics. So we have the dirty gas that comes in here, and then the gas is spun very, very quickly in this direction, very, very quickly. And because of the centrifugal force, it forces the particles to go out to the side of the drum. And as the particles collect, they start to drop down into the hopper. So eventually the flue gas will then go down and come back up and go out to the actual smokestack, and clean gas comes out. Now when you put all three of those together, you put an electrostatic precipitator, you put a cyclone separator, and you put baghouse filters on a power plant, the power plant at that point has almost virtually no particulate being released at all. And it's a very efficient way to clean up flue gas. The last type of filtration I want to talk about is the wet scrubber, and also known as desulfurization. The flue gas comes in through here, but then at the same time you get crushed limestone or lime powder and mix it with water, and you make a slurry. And then the slurry is sprayed into this wet scrubber unit. So you have the slurry coming out here, you have sulfur dioxide coming up here, and what happens is a chemical reaction between the sulfur dioxide and with the mercury in it as well, and the calcium form gypsum and in a slurry at the bottom. And then the clean gases without any SO2 then can be taken out to the actual chimney, where we get a lot of steam coming out. At our local power plant, we see lots of light clouds of steam coming out the top, and this is because our power plant has, I think, about 6 wet scrubber units on it. Now, as this slurry starts to collect, then they pump it out. They filter out any solids from the slurry, and this is gypsum, and then the gypsum can be recycled as wallboard. And so the wallboard that you have in your house, or even the wallboard in the classroom, might have come from the gypsum used to clean up the flue gas from your local power plant. Now, some other types of treatment technology. We'll look at some of the traditional ways to get rid of air pollution in the past. We could have moved the factory to a remote location. If you have lots of space and you can move factory away from people, then that helps reduce the amount of air pollution illness in that area. You could also build taller smokestacks. The higher the smokestack, the further the wind will blow the pollution away. So we got a very high stack here. Some newer methods are biofiltration. So some of the flue gas vapors are pumped through soil where bacteria then can degrade the actual compounds. This works very good for NOx. Remember the nitrogen cycle? A lot of the nitrogen cycle happens in soil, and if you take that flue gas that still has NOx in it and you filter it down through soil, the bacteria in that soil can then start breaking that NOx up into something more useful. Another way to do it is through high energy destruction. So you run the flue gas through plasma. Plasma is like lightning. It's one of the hottest forms of matter we know. And by removing this gas through this plasma, it breaks all these things down into their constituent elements. So instead of getting NOx out, you get nitrogen, you get oxygen. You get just sulfur, which would be collected and reused in some other kind of process, and you get just oxygen for sulfur dioxide. So this is one way to. The problem with this is that you use a lot of energy to do this, and it's not very efficient. You could do membrane separation, diffusion of the vapors through a semi-permeable membrane. And then another thing you can do is oxidation. So you have another high temperature combustor and you add lots of oxygen to that, and the oxygen then reacts under this high temperature with these things and makes them less toxic. All these are much more expensive than our current day filtration techniques. This one, the biofiltration, actually has the most promise out of any of these. There's not a whole lot of energy wasted with this one. So how do we get rid of air pollution? The best way to do it is prevention. Don't create it in the first place. So there are some technologies out there that can avoid actually creating the pollution in the first place. Sulfur removal from coal. You can take crushed limestone with the fuel, with coal, and you could combust the whole thing at one time with the limestone in there, and the sulfur in the coal automatically reacts with limestone to produce that gypsum. So you don't have to have a special scrubber at that point. So you didn't produce the pollutant, you just kept it from forming. And nitrogen oxide control. You could do stage burners or catalytic converters. Catalytic converter in your vehicle actually takes care of a lot of NOx particles. And so you could actually have large catalytic converters for power plants. You could do hybrids, electric hydrogen powered vehicles. We're starting to see a lot of hybrids with the Prius and other ones out there. This is one way to get rid of those NOx's and VOCs. Partial zero emission vehicles, hydrogen vehicles that only emit water. Get the older cars off the road. There's always seems to be an older car around here that you get in back of, and you start smelling this nasty exhaust from this old car. And if there was some kind of program where we would give people who have really old cars incentives to get them off the road and get them into a new car with better pollution control, that would be very helpful. And then another one is increase that energy efficiency and reduce the energy waste. If we could do that, then we wouldn't put out as much pollutants because we wouldn't have to produce as much power. And this is probably one of the biggest bangs for our buck. So how do we reduce indoor air pollution? Ban smoking indoors. This has basically become very commonplace, especially in the United States. In Europe, it's just starting to take hold. But in the United States, most public buildings don't allow smoking. You could use a lot of different fresh air vents, adjustable fresh air vents. So you could bring air from the outside and circulate that inside and get rid of that indoor air pollution. Better circulation is always better. Control for food and grease particles that come out of preparation of food. Install efficient chimneys in fireplaces. Office machines. Office machines actually produce a lot of indoor air ozone. Because of all the little electric motors inside of them, they produce a lot of little sparks, and this creates ozone. And if you have a copier or a bunch of copiers in a closed space, you can build up a lot of ozone in that small space fairly quickly, and that can be very dangerous to your health. So getting these in well ventilated areas is very good. And then radon detection on prevention. Very few people actually test for radon in the United States. I think it's fewer than 24% of the households in the United States have been tested for radon, even though a majority of them still might have radon in them. And once it's detected, then actually fix the house so you prevent the actual radon. So these things can actually reduce the indoor air pollution problems that we have. Once again, not too big a problem in the United States because we do typically have adequate ventilation. However, some of our buildings need some of these things. Well, I hope that gave you some more insight on the technology involved in controlling pollution. And if you have any questions, please bring them to class.